Friends, welcome to this class. So now we are discussing stereochemistry of nitrogen, right? Let us continue with that. So in last class we saw that as we increase the steric hindrance to the nitrogen, the rate of inversion increases. If you see rate of inversion, it is easily inverted compared to this and this one, right? So we know that. So here you can see initially the component will be like this. In one of its transition state, it becomes planar like this. Further, it will get inverted. Right, lone pairs will be here like this. Now it is here. This inversion we call it as pyramidal inversion. Right. In one of its state, that is transition state, the bond angle is 120 degree. Means all are in same plane. Right. So that is the thing. So here, because of steric hindrance, repulsion will be more. Because of repulsion, it can easily go to this planar structure compared to this. So it will get easily inverted. So, and we know that greater the inversion means energy will be less. So both are inversely proportional. So if rate of inversion is more, then energy of inversion will be less. Both are opposite, right? So here rate of inversion, this will go very fastly, so its energy, if you see, it will be very less. That is how you should remember, right? So coming to this cyclic ring, I told to decrease the inversion, what we can do, we can take a restricted molecule. Here this is restricted because its energy is more than room temperature, and we know that room temperature it is 20 kilocalorie per mole. Right, so that is the energy. If this molecule energy is more than that, so here no inversion. If I increase temperature, no doubt inversion happens, but the temperature I should increase. If its energy is 50 kilocalorie per mole, I should increase the temperature energy more than that 50, then only inversion happens, right? So these compounds can be easily isolated, right, because no pyramidal inversion. The reason for that is, see here, if you see the bond angle, it is 60 degree. To happen pyramidal inversion, all these compounds will be having 107 degree. One of its transition state, here the bond angle will be 120 degree. Again it is inverted to 107 degree, right? So from 60 degree to 120 degree, it can't happen. If it happens also, this ring is there, right? That can easily broken. Whereas here bond angle is what? 90 degree. Here it will be around 105 degree, and here it is like 107 degree, 108 degree the bond angle. So from 60 degree to 120 degree it is very difficult. Whereas here 4-membered ring, 90 degree to 120 little easy. From 105 degree to 107 degree easy. It is very easy because 107 degree only. So if you see the rate of inversion, the 6-membered ring will easily inverted. So it will show pyramidal inversion or the oscillation. See, 6-membered ring, 1, 2, 3, 4, 5, 6. Here it is 5, 1, 2, 3, 4, 5. 5-membered little less. 4-membered, 1, 2, 3, 4 less. And this is least, or I can tell that it is no inversion here. So it is the rate of inversion. If this is the rate of inversion, energy will be opposite to it. Since it is easily inverting, but energy will be very, very less. If order of energy, it will be having more than this, and then it comes, right? So that is the energy order. Because you should know both the things, because they ask you energy, right? So if you remember one thing, that will be opposite to it, right? So these are the things which we have seen in previous class. So now let us see the effect of conjugation. For example, here I have a molecule like this. So here they have taken phosphor. With phosphor also we shall discuss what happens with phosphor and everything. Here I have 6-membered ring, and here I have isopropyl, and here they have taken one more molecule in which benzene is there, para position NO2, and here we have methyl, and here we have isopropyl, and the last one, that is this compound they have taken. Here they have got benzene ring, same methyl, same isopropyl, and lone pairs. So they have named it as A, B and C. Now they are asking what is the rate of inversion. Inversion rate now. Lateral rate, inversion, energy. See, now I will tell. Whenever there is conjugation, right? So if you see the more number of conjugation is more for this B. So this is the order of conjugation. Conjugation is more for B. Then comes C. Here no conjugation because no benzene ring, no conjugation. So it is A. Why B is more than C? Because NO2 group. NO2 group is the world's best electron withdrawing group. So it can easily give the lone pair. So conjugation happens. So here we will get partial double bond. So partial double bond means it will be like this. P double bond, and here we have like this double bond NO minus. So that will be the structure. Other things will be like methyl and here isopropyl. So all will come in same plane, that is 120 degree, because of double bond. So it can easily come into single plane. So it can easily come into 120 degree because conjugation is more. Here conjugation is less because no electron withdrawing group like NO2. So order of conjugation is BCA. So since more conjugation means it can easily come into 120 degree, that is planar structure. Once it comes to 120 degree, again it can easily invert, right? So oscillation can happen. So the rate of inversion will be more for this B, then comes C, and least for this A. So what you understood? Whenever there is conjugation taking place, those compounds can easily be inverted. Why? Because they can easily go to the transition state whose bond angle will be 120 degree, that is planar. Because of conjugation they can have this planar structure, so easily they can invert. So order of inversion will be BCA, right? Energy means opposite to that. Since it is going easily, inversion means its energy will be least, whereas this is going lately, inversion means its energy will be more. So energy of A will be more compared to C compared to B. So energy order will be exactly opposite of the rate of inversion, right? So that is the thing. So this is about what conjugation effect, right? Once we know all those things, let us discuss few more concepts so that we will appreciate this pyramidal inversion and you can answer so many questions, right? So let us see for these compounds. So these compounds we call it as Dragos compound. Dragos compound, which you will learn in inorganic chemistry. Dragos compound. For example, nitrogen family, what it is? Nitrogen, phosphor, arsenic, napas, sabe. This is bismuth. This is antimony, right? So if I take this NH3, PH3, ASH3, SBH3 and BIH3. Now they will ask rate of pyramidal inversion. What is the rate of pyramidal inversion, they will ask, right? The answer is C. If you see the bond angle of NH3, whenever we will tell the hybridization of the bond angle, we will count the number of lone pairs and sigma bonds. So it is 1, 2, 3, 4. So count the number of sigma bonds and lone pair. So it is 4. You will tell sp3, right? So this is the hybridization you will tell. So here, because lone pair bond pair repulsion, the bond angle will be 107 degree. Sorry, 107 degree, right? If you see this phosphor PH3, phosphor belongs to same nitrogen family, right? So structure should be same, you will expect. And hybridization also you will expect the same. Hybridization you will expect it as sp3, right? So bond angle you will expect it as 107 degree. But this is wrong. The reason is these compounds PH3, ASH3, SVH3, these are called as Dragos compound, in which these lone pairs are there, right? Lone pair present on phosphor, lone pair present on arsenic, lone pair present on antimony, lone pair present on bismuth will not participate in hybridization. That rule is nothing but Dragos rule. The compounds which have phosphor, arsenic, Sb and bismuth, the lone pair present on central atom, that is phosphor, arsenic, Sb and Pi, and the surrounding atom, if its electronegativity is less than 2.5. We know that electronegativity of hydrogen is 2.1. If electronegativity of the surrounding atom is less than 2.5, in such case the lone pairs will not participate in hybridization. That is nothing but Dragos rule we call, right? So about that rule, if I will make a separate video, no need to worry, right? So what you understood, these lone pairs which are present on phosphor, arsenic, Sb and these will not participate in hybridization. So what happens is that, see, this phosphor is there, so nitrogen, it will be like this. Nitrogen valence electron will be same for phosphor also. So this is nitrogen. In case of nitrogen, what happens? It will undergo sp3 hybridization. This is S, this is P, Px, Py, Pz. So 3p. So it will have sp3 hybridization. So phosphor belongs to same nitrogen family. So valence electron will be same. For phosphor it is. Yes, and there will be 3p. But according to this Dragos rule, the lone pair present on the central atom, that is phosphor, will not participate in hybridization. So it won't participate in hybridization like sp3. It will remain as it is. So what happens? Now 3 hydrogens are coming. So 1 hydrogen, 2 hydrogen, 3 hydrogen. Just they will combine like this. No hybridization here. So if you see P, so P means Px, Py, Pz. These things will be there, right? I hope it is clear. Yes. Px, Py, Pz. 3 things will be there. So here Px, Py, Pz. So this is Px, Py and Pz. X, Y, Z. All are 90 degree. Right. So if you see bond angle of this PH3, it will be around 90 degree. Right. Whereas for NH3 it is 107 degree. Whereas for phosphor it is 90 degree. Why it is so? Because the pure p orbital will have bonding with the hydrogens, and these lone pairs will remain as it is. So they won't undergo any hybridization. They won't participate in hybridization, because of which the bond angle will be 90 degree. Right. Similarly, as we go down the group, here also no participation of these lone pairs. So what happens? Is that, see, for this bond angle is how much? 107 degree. For this it is around 90 degree. Right. So in one of the transition state, bond angle is 120 degree. So from 107 degree to 120 degree, it can be easily converted. Whereas here for PH3, from 90 degree to 120 degree, the energy required is more. So this inversion will be slow. If they ask you, if they give you these 3 compounds, NH3, PH3, ASH3 and SBH3, if they ask you for the rate of inversion, what you should tell? NH3 will be more easily, it will be inverted compared to PH3, then ASH3 and SBH3. The reason is I have explained, that is here no hybridization and these compounds are called Dragos compound. And one more reason is energy. Energy for this SBH3 will be more inversion energy compared to this and this. So for example, if this is NH3, so this is the inversion energy, right? So here the molecule will be like this. Now it has been inverted like this, and lone pairs will be below, here lone pairs will be above. Here it is a transition state like this, right? So this is the transition. If this is the energy for PH3, it is like this. The tunnel, something they call tunnel, they will call the wide and the height both will increase for PH3. For ASH3 again it is increased like this. So what happens? Here the rate of inversion will be more compared to this, right? And this is little more compared to this. Like that they concluded, right? So if this is the rate of inversion, then energy of inversion will be exactly opposite to it, right? So we discussed so many things, right? right? If I want to give you the rate of inversion, see, I can tell you for nitrogen the rate of inversion or rate of oscillation is so high, 2.3 into 10 to the power 10. 10 to the power 10 means, you know, for in front of 1 there are 10 0. So fast inversion it is shown by nitrogen. Pyramidal inversion, this is nothing but rate of pyramidal inversion. So fast nitrogen will show. Compared to phosphor, see, for phosphor it is 5 into 10 to the power 6. You just neglect this 2.3 or 5. Just you see this thing. It is 10 to the power 10, whereas this is 10 to the power 6. So slow, right? Because 10 to the power means 10 means so many tens in zeros in front of 1, right? So it is less. If you compare with this arsenic, now you will see it is 16 into 10 to the power 4. See, as we go from nitrogen to phosphor arsenic, the rate of inversion is increasing. Rate of inversion for nitrogen is more compared to phosphor. It is 5 into 10 to the power 6, right? And for arsenic it is still less. It is 10 to the power 4. You should not see this 2.3. 5 is greater than 2.3. 16 is greater than 5. That is not the case. This is very important. This is very significant. 10 to the power 4 is very small compared to 10 to the power 6 and 10 to the power 10, right? So this is the rate of inversion and this is the order of energy, right? And this is the data from which we will tell that this order is correct, right? So this data you should not remember, but to tell you exact, I should explain it. I have done my work, right? So one more thing if I want to tell, so I told if I have pH 3 like this, the inversion will be like 5 into 10 to the power 6 for this pH 3, right? 5 into 10 to the power 6. Just if I increase the mass of, instead of hydrogen, if I take this deuterium, just I increase the mass of the hydrogen, that is isotope, that is deuterium, the rate of inversion will be decreased 6 into 10 to the power 3. See, 10 to the power 6, 10 to the power 3. It has been halved, right? So it invert fastly compared to this. No inversion. If you see energy, its energy will be high. What energy? Inversion energy, right? So no need to get confused. So this is the thing, right? I hope I covered so many things, right? So these are Dragos compound. So about Dragos compound, in later I will explain it in inorganic chemistry, right? What are Dragos compound? Some exceptions they will come. You will see there, right? Sometimes they will ask in exams. They will ask a question like, see, I have here N fluorine they have taken. Next N chlorine they have taken. Fluorine, chlorine, bromine and iodine. Instead of taking, let me take methyl. And they have mentioned A, B, C, D. You have to tell rate of pyramidal inversion. Next, energy of inversion. Order you have to tell. And I think you have studied about one concept in which they will tell that whenever the electronegative atom attached to central atom, it will attach in such a way that this bond will be having less S character, right? So we know that if C triple bond CH, so your S character is more because it is sp hybridized. S character is 50%. If I take C double bond C and H, it is sp2. This carbon is sp2. S character is around 33%. If I take sp3 like CH4, the character is 25%. S character, only S character it is, right? Whenever I have more S character, the bond angle will be 180 degree since it is linear. Here bond angle is 120 degree, whereas here sp3 the bond angle will be 109 degree, right? So whenever S character is more, bond angle will be more. And I told electronegative atom are there, right? they will be attached to nitrogen, in which s character should be less, because electronegative means they have ability to hold the electron, right? If s character is more to the central atom, then that electron it should give, but the electronegative atom they will hold the electron, so they will attack to the central atom, in which the orbital should have less s character. So here less s character means bond angle is less. Here compared to this, bond angle will be more. So here you see, let us assume that bond angle is it will be around 107, right? So it is less. Let us assume it is 105. Still it is more, 105.5. Let us assume it is not the correct data, right? And now it is 106. For methyl, here s character will be more, so bond angle will be more. So its bond angle is, let us say that it is 107 degree or 108 degree. Let us assume like that, right? So this is the order of bond angle, right? Bond angle. So this is the order. Now what they have told, rate of inversion order they have asked. The order will be D will be more, then C, then B, and last A. You will ask why, sir? Because in inversion we want what? Like this compound, in which 120 degree is there. So from 108 degree to 120 degree it can easily come. So inversion will be very fast. So D, next 106. So C, next 105.5. So B, last A, because its bond angle is 105, very less. So 105 to 120 degree difference is more. So it can't easily come to 120 degree. So this is the order. Once we know the rate of inversion order, then we can easily tell the energy. So energy means what? So since it is easily inverted, its energy will be very less compared to C, compared to B, compared to A, like that. So if you know the rate of inversion, the opposite is the energy of inversion, right? So that is the thing, right? So I hope you got everything, and also I guess I covered everything, right? So that is the thing, right? So this is all about pyramidal inversion or the oscillation, right? So this NH3, N-methyl 3 all called rotomers. In next class, let us see few more thing in the stereochemistry of compound other than carbon, and we are discussing nitrogen in next class. Till then, take care and have a great day.